Okay, we're going to work with quadratics a little bit. They're equations, quadratic functions, finding the zeros, and doing some modeling problems, like how do aquatic equations get applied in real-world situations. So to begin with, we have this pretty basic quadratic expression here, quadratic equation. I added the equal to 0, and I'll re-add it in a minute. Got this quadratic expression, and typically quadratic expressions get factored to two binomials. And the process is pretty simple. The first term gets factored, so x squared is x times x. And then the second term, I'll do it this way right here, or the third term gets factored to the two second terms inside the binomials. You have to be careful with doing this because we could have chosen -8, +1, +8, -1, +4, -2, -4, +2. And I chose -4, +2 because when you do the double distributive, so x times x is x squared, x times 2 is +2x. So I just multiplied those two things. Now I'm going to multiply -4 times x is -4x, -4 times 2 is -8, and then look at what we have right here in the middle. Like terms, and when we add those like terms, they add up to -2x. And then we're back to our original quadratic. So when you're factoring these things, you have to keep in mind that when you multiply them out again, they have to equal what the original quadratic was. So again, all I did was factor the x squared into x times x. -8, I factored to -4 times +2 because -4 and +2 add up to -2. Right, so we're going to try a little bit more difficult one. We have now a quadratic with a leading coefficient of 2. Now, the nice thing about this is that because 2 is prime, we still can factor 2x times x is 2x squared. Well, then we have this third term, -5, and -5 needs to factors of -5. So here's the tip. The tip is this. Let me go ahead and switch back to a pen. You have to be really careful about where things go, all right? So, well, let's do it this way. Well, factors of -5 are 5 and -1 and -5, +1. So if we put +1 here and -5 here, look what happens. 2x times 1 is 2x. -5 times x is -5x. When you add those two together, you get -3x, but what are they supposed to add up to? They're supposed to add up to -9x. So that one will not work. So the other option is, well, we could do -1, +5, but what, or +1, -5, but this is what we're going to do. I'm going to put since that's -9, I know that this has to be a big number. Well, 2 times -5 is -10x, and then -5 times +1, and look at, this is why I chose that. 2x times -5, 2x times -5 is -10x, and then 1 times x is 1x. Add those together, and you get the very important -9x. Now, for those of you who prefer the table method, this is the process. When you have this quadratic, it's, and here I've labeled A, B, C, it's A times C, so 2 times -5 is -10. Factors of -10 that add up to -9. So which factors are they? Right here, but be careful. You then have to take those two, and we're going to do the grouping method. When the leading coefficient is not 1 and you use the table method, you have to then do the grouping method. So we're going to take this 2x squared minus 9x, subtract 5, and we're going to, instead of putting 9x the next time, we're going to change that 9x to negative 10x plus positive 1x. So, and I'm going to put the negative 10 with here, so negative 10x plus 1x. I did that very far away. Subtract 5, and now we're going to do the grouping method. So we're going to put parentheses here, and 2x squared minus 10x have a 2x in common, leaving x subtract 5. And over here, the only number they have in common is 1, leaving x subtract 5. They both share an x subtract 5, so I'll factor that out. And everything on the outside of the parentheses goes in the second set. And it's okay if you put 2x plus 1 first, then x minus 5. That part doesn't matter. And then look at what we have. X is equal to 5, and x is equal, well, the opposite of 1 is negative 1. The opposite of multiplying 2 is dividing 2. Okay, and then notice on this, I don't think I covered it. When you're finding the roots, when you're factoring and finding roots, the roots are where the graph is going to touch the x-axis. So x is equal to 4, x is equal to negative 2, and we know it's a parabola, so halfway between those, there will be a line of symmetry. So at positive 1 on the number line, there'll be this axis of symmetry, and then somewhere down here will be the vertex. Just like that. In fact, if you put 1 in there, you'll be able to figure out what that equals. And it looks like it's probably going to have to go lower than that, maybe. Something like that. All right. Then you can have equations in what we call vertex form. The cool thing about vertex form is it tells you exactly, that's a very bad drawing of a parabola, it'll tell you exactly the exact vertex point, either the low point or the high point of a parabola. Could be this too, or the leftmost point or the rightmost point. Okay, so when it's in this form, notice what we have. We have y subtract 2 is equal to, in parentheses, x plus 4 squared. The opposite of 2, so let's go ahead and put that in parentheses so that's easier to think. The opposite of negative 2 is positive 2. That's the y value. The opposite of 4 is negative 4. That's the x value. There you have the vertex. So if you were to graph that at negative 4, positive 2, you might have a parabola that goes up like that, or you might have a parabola that goes down, depending on whether there's a negative sign in front or not. Another way to see the vertex form, over here, they have not added the k to both sides. So on this side, the only difference between the two is the k has been added to this side. So in the example problem, if I add 2 to both sides, and now notice, the 2 is no longer in parentheses with the y. So remember what we said about vertical shifts. We know right away that that plus 2, that's where you're going to go up 2 on the graph. That 2 is the y value. And still, the opposite of the negative 4, the opposite of 4 is negative 4. That will be the x value of the vertex. And then, okay, I'm going to have that be it for this one, and one more for quadratic equations.